Well, greetings, everybody. I have the top of the hour, so we're going to go ahead and get started with our webinar this month. I'm Greg Freeby, the Executive Director of the American Segmental Bridge Institute. I'd like to encourage you to follow me and the American Segmental Bridge Institute on LinkedIn if you're not already. It's a great way to keep in touch with some of the latest things going on in our industry. Hopefully you're here today for our monthly webinar on the cast in place segmental project at the LAX airport using form travelers, and I'll be introducing our speakers here in just a little bit, and we'll get going with the presentation. But I do have a few announcements I want to make ahead of time just to get you a little oriented with the webinar, but also to talk about some other upcoming events. Again, this webinar is the first one for this year, 2024. We will do a webinar every month through probably October, September, October. We don't typically do a webinar through the holidays just to not compete with that. Each webinar is the last Wednesday of each month from noon to 1. Registration is open on the ASBI website, usually about a month before the event. And recordings of past webinars are also available. You can find them on the ASBI website, or you can also find them on our revised YouTube channel. If you just search ASBI Concrete Segmental Bridges on YouTube, you should be able to find this landing page that gives you direct access into all our previous webinars. Our webinar next month will be on Wednesday, March 27th. Mr. Alp Kanner with WSP will be talking about monitoring of closure segments on post-tension box girder segmental bridges built by the cantilever method. So registration is already up for that webinar as well, and we look forward to that presentation. Also coming up in April, on April 1st, we have an in-person session of our grouting certification training in Austin, Texas at the J.J. Pickle Research Campus on Burnett Road. Registration for that event is open on the ASBI website, and this is the only grouting certification training we have currently planned for 2024. I put 2025 on the slide, sorry for the typo. But it is 2024, and this is the only event we currently have planned. So if you have need for grouting certification training, the ASBI training is required per the PTI specifications, so I'd encourage you to sign up for that training. Later, also in 2024, October 20th through 23rd in Atlanta, Georgia, ASBI will be hosting our annual convention and committee meetings. We're going back to the more traditional schedule of the committee meetings happening on the Saturday and Sunday before. Convention begins on Monday and runs through Wednesday noon. So again, that registration isn't open yet. It will be in the coming weeks, but encourage you to go ahead and put that on your calendar. Just a little reminder about our construction practices handbook. This series of webinars is being promoted by our construction practices work group, and this product is one of the end results of this group's work is our handbook. You'll find a whole lot more information about some of the topics we'll cover here today about form travelers. You'll find more information. It is a free publication for electronic download, and you can find it on the ASBI website. Another announcement I will make on behalf of the National Concrete Bridge Council is April 24th and 25th in Atlanta, Georgia. NCBC will be hosting a pre-stressed concrete bridge seminar. This is a seminar for learning advanced concepts for extending span ranges. So you'll learn more about segmental bridges as well as other long concrete girder techniques for extending spans. There's a QR code there on screen you can snap if you want to register, or the URL as you see also on screen. I also put a copy of the flyer in the handouts, so if you go in your GoToWebinar dialog box, you should see a handouts click. If you go to the handouts, you can then download a flyer for this webinar series if you need some more information to circulate around your office. Encourage you to sign up for that. Again, it's coming up quick, just in April, so go ahead and make plans now to attend that seminar. There's a lot of really great instructors and 2 full days of training. The training does include breakfast and lunch as part of the event, so it's a very intensive but a great learning opportunity. So some quick instructions on how our webinar works. If you lose your connection, you can rejoin using the link that you were provided. You, of course, will miss a little content while you are away. Try to minimize that. We are issuing certificates of attendance for professional development hours to those that meet the minimum required in attendance. And please allow at least a week for your certificate to arrive via email. And we will do a Q&A at the end of the presentation. And the way this works is in your GoToWebinar dialog, you should see a little questions pull down. You just hit that little button, and you'll be able to type in your questions, and go ahead and do them as the presentation is going. That way, our Q&A moderator will collect them up, and we'll have a moderated Q&A session at the end. If you're on a mobile device, you can also input questions. There's a little question mark in the upper right-hand corner of your screen where you can type in your questions. This is our administratively required slide to mention that we do meet the standards required by the Registered Continuing Education Program, RCEP. That's where you'll receive your certificate for professional development hours through RCEP. Our Q&A moderator today is Mr. Wade Bonson. If you've been with us in our past webinars, Wade has been serving as our Q&A moderator as the chair of our construction practices work group. He's the vice president and director of operations at FIG Bridge Inspection. He has a BS in civil engineering from New Mexico State University. He also holds a master's degree from the University of Texas, has more than 25 years of experience in the industry, a lot of experience in segmental bridges, and is outstanding engineer, registered in more than in 10 states. So Wade will be joining us at the end of the session to serve as our moderator for Q&A. Our speakers today, and my apologies, I have them out of order. So I'm going to introduce our second speaker first and then the first speaker. Pawel Okolowicz is an engineer with more than 17 years of experience in the industry. He studied at technical universities in Poland and Denmark and graduated as a master engineer with specialization in structural engineering. He began working for PERI in 2010 in Poland, and in 2016 he moved to the headquarters in Germany, where he's responsible for managing balanced cantilever projects around the world. Since the early beginning of his career at PERI, he's been closely involved in the further development of balanced cantilever systems. And just a little side note about Pawel, when he's off duty, he's a husband and father of a 6-year-old daughter. He's passionate about timber framing and passive buildings. He built with his own hands and renovated a number of homes, and most recently a timber house that he and his family currently reside in. So Pawel will be our second speaker. Nabil Bouabid, also with PERI, is the national head of strategic projects for the Civil and Infrastructure Division at PERI USA. An accomplished professional with over 30 years in the construction industry, 20 years of those in management and engineering. In his 24-year career at PERI, he has had significant roles in business development director, as a managing director, contributing to national business development in the heavy civil and infrastructure division. He has a diverse range of experience managing projects in Algeria as well as in the United States. Outside of work, Nabil is a dedicated family man with 4 children, ages 2 to 19, which keeps him busy when he's off the clock. And he also holds a black belt in judo with a lifetime membership in the U.S. Judo Association. He's also very passionate about soccer. So with that, I want you all to welcome our speakers. I will step back now and let Pawel is going to do the presentation, but Nabil is going to make some introductory remarks here for us first thing. So with that, gentlemen, I'll turn it over to you.
Thank you, Greg. Pawel, can you go to next page, please? Again, quick introduction. My name is Nabil Bouabid. I've been with PERI for 24 years. I'm a Purdue graduate with a civil engineering degree, technology degree. And Pawel, could you introduce yourself, please, as well?
Yes, hello. Thank you, Greg, for a nice introduction. I just want to add that during these 14 years with PERI, I was during all that time actually involved with our balanced cantilever system, and at the beginning I was a supervisor at the job site at the assembly. I was also a design engineer, and now I'm doing project management for worldwide projects where we have our balanced cantilever system. If you want to, Bill.
Thank you, Pawel. Thank you very much. Could you go to the next page, please? I'm having Pawel presenting, so you're going to hear next a lot, guys. I apologize. We're going to be discussing today, of course, the LAX project, and we're going to go over a general overview of project, introduction to ballast cantilever. We're going to speak a little bit about customer requests as well, and design processes that Pawel is going to present for us. And later we're going to talk about field challenges, assembly and disassembly. And of course, after that, we're going to move into a Q&A. Next page, please, Pawel, and next one as well. LAX project is to moderate the LAX and alleviate the heavy congestion that is typical in and around LAX. The LAX MPN project is about 2.25 miles along elevated guideway, and it will be transporting passengers between 6 stations over the alignment. 3 stations are within LAX terminal area, and 2 are at the parking garage transit center. And the final terminus is the new consolidated rental car facility. LAX Contractors JV is the contractor, and PERI, we were working directly with Flatiron on this project. PERI USA was awarded the cast-in-place segmental scope on the project only. We worked on the 1 GW1 Westway Street spanning over the parking lot with double span cast-in-place segmental. And also we had as well 1 GW4 spanning over Spovilda Boulevard, single span cast-in-place segmental. And as well, the last one was the last span is the 1 GW5 over Century Boulevard, single span cast-in-place segmental. And this we will be mostly discussing on this presentation. This bridge, the contractor chose to do first, and it's 47 span between bend 47 and bend 48. The length is about 195 foot. Radial curve of 387 and 387 inches and 387 foot. Sorry about that. Approximately, with an incline of 1%. We delivered 3 pairs ballast cantilever, which is 6 carriages with variokit formwork to do 3 viaducts, and basically 4 span total. And the delivery was done on December 1st, 2020. Next page, please, Pawel. Next one as well. Little overview of PERI ballast cantilever, as it's a very simple, straightforward here. We see the yellow frames on the top, and later you have the front main beam, well, the bottom platform is suspended from as well. You have the main truss, which hold everything together, and as well the bottom platform in the rear is suspended from it, and you have the carrying rail for the carriages. Okay, and we see the carriages and the carrying rail that are basically anchored to the deck with 2 rod or 2 anchors each. Next page, please, Pawel. We see here as well the internal formwork, the bottom platform, and as well we have the external formwork, straightforward system. The next one, please, Pawel. As well, next one. The challenges of this project, of course, the most concern from our contractor is the safety and traffic underneath the carriages. As well, the traffic cannot be shut down. It's an airport, so they had to move, they had to shift traffics as needed, so cannot fully shut down. And as well, the challenges is the tileless bottom adjustable platform as we cast the geometry of the segment changes, and we have to make sure you cannot break the formwork down, has to be adjustable in place, and has to be as well safe, and nothing coming through that platform while there is traffic. I will turn to my colleague Pawel. He's going to discuss a little bit about geometry and design process for this project. Please go ahead, Pawel. Thank you.
Yeah, so thank you, Nabil. I will speak a bit more about these viaducts, which were in scope of our part. So first, the longest one was a 2-lane viaduct spanning between these piers here. This part actually was done over the parking garage. And if you look at the technical drawings, you see that it's a 2-lane bridge. What is interesting here is that actually the span itself, as it was designed, was not really symmetric. The left side here was 9 segments with 15 feet each segment, and on the right side here there was only 7 segments. So there was also a closure pour which was 7.5 feet long. So that was the longest, and then the next one over Sepulveda Boulevard, already above the traffic, yeah, so more critical than above the garage, and it was a 6 pouring segments at each side of the span, plus of course the closure. That was already a little bit curved one. Still, the curve is not so bad, not so critical. We don't need any special operations for such curves. But then if we look at that one, I would say that was the most challenging one, because that's again above the traffic. That's actually the main entrance road, the Century Boulevard main entrance road here to LAX terminals. And that was actually also the most interesting, because it had this radius. It had a curve. We had to turn with the carriage a lot. The curve radius was 387 feet. And also another interesting thing was that these segments was 6 segments at each side, but first 3 of them were 15 feet, and then shorter ones 12 feet, plus of course the closure pour a little bit more than 7 feet. That's already a nice picture that I got from Flatiron. Thank you for that. Nice view on the construction of that viaduct. So let's go to the concept. So to speak more about the details, how did we approach the job at the early stage? First, when we are getting the geometry and we are planning our solution for it. For us, the most important is to find out what is the geometry to which we are planning the system. Yeah.
Pawel, I'm gonna stop you for a second. Could you adjust, please, your screen? Thank you. It's zoomed in too much. You are zoomed.
Really?
Yes, please. Thank you. I don't know if.
I mean, at my screen, everything looks okay.
No, it's fine. Okay, then it's my screen. Sorry about that.
Yeah, it's fine.
Okay.
Okay.
Good. All right.
So anyway, we are getting back to that. And so speaking about the geometry of the bridge, you're looking here at the cross section at 1GW1. Pretty typical with inclined walls. And then there was 2 more viaducts, and very important for such project is to minimize variations of the system. If we have 3 viaducts, the best would be that we could actually use the same carriage. And actually design here was very nice, because if you look at 1GW4 and 5, they were a bit lower sections, and only difference beside the height difference of the cross section was the wings, the side cantilevers. It was just a little bit longer in 1GW4 and 5, but again the envelope was the same, so that led us to the situation where we can actually design the same framework for the complete solution. The same about the formwork, just with a little bit differences, but at the end that was a very good information for us. That's the way how we would like to have the bridges designed normally. There is many piers and many viaducts. So what you see here is actually the first approach. This is how we approach normally. We designed this first concept as we think it should be good, even before talking with our customer, to aligning with their expectations. So here you see the top part is actually situation at the pier, and here below is a mid-span situation. Important to show both, because we want to show how our carriage, especially in the bottom part when the cross section is getting smaller, behaves. Also important thing is, especially for cross sections with the inclined walls, is that as the walls are inclined and the cross section is getting smaller, at the same time the bottom slab is getting wider, which you can see here. So we need to have expandable formwork. So what you see here again is our cross section. A and CC are above the concrete where the truss is, so that's the truss. Then in the front there is a main beam here, and the bottom platform underneath, suspended to the truss and to the beam. Next slides, we're gonna focus a little bit more on these ones, just to zoom a little bit more. So our initial concept and our standard solution for such bridges is to have external formwork overlapping with the bottom slab. That requires openings here. So as you see here, the external formwork is just wall actually sticking out a little bit down. But as I said, that requires here to have openings. Then also another thing, speaking of our standard approach, is these side walkways. We have these side walkways in order to avoid having any tie rod in the bottom slab or underneath. It's just that these walkways, if you look at them from a top view, they are trusses which are pushing the external formwork to avoid having the tie rods here underneath. They are just transmitting the pressure of a concrete to this beam. So this beam is kind of a tie rod. And then one last thing, speaking of the bottom platform, is the expandable formwork. As I said, the bottom slab needs to be expandable because it's getting wider as the cross section is getting smaller. So these trusses here, you see them as a beam, but they are actually trusses. They are slidable, especially the ones on the side. So that was the first concept which we presented to Flatiron. Then also there were some discussions later about implementing a rear trailing platform, which was supposed to be connected to the bottom platform. So it's kind of a tail from which you can access the previously constructed segment. And that is to do all the patchworking on the tie rod holes. You can also patch the anchor holes, or just do a simple cosmetics, yeah, if required. And then also, due to collision at the beginning with the pier, it was possible to hinge it down and then hinge it up after in the moment when we are getting actually to the segment where there is no collision anymore. But this was terminated, especially due to the fact that we are working above the traffic, and this is much bigger area to secure against any debris falling and so on. So this was terminated. That's already close to the final concept, and after several discussions with Flatiron, we realized that yes, there is a traffic underneath in most of the cases, and we cannot really allow anything falling down on the street underneath. So there was a decision, there was a solution worked out together with Flatiron to make a full planking, fully closed planking on the bottom platform. There should be no openings, so this way nothing can go through and fall down. And the change in comparison to initial solution was that this external formwork was cut here. So anytime we are approaching, we're launching the carriage to the next segment, this formwork needs to be cut as the cross section is getting smaller, and that is actually pretty normal situation for internal formwork for all of the bridges with the changing height. We do like that, and then this part is just made of timber, so you just cut it. And then also the tie rod was put underneath the bottom slab. Yeah, it was the bottom platform was a little bit lower. Here we had timber, and this was the way to secure the bottom part, especially here when the bottom slab is higher. We have a bigger pressure from the concrete in the bottom part. So here we had our tie rod. So that was 1GW1. You see 4 carriages used here, and you can also notice no external formwork is sticking down, nothing is overlapping. The same story here, already above the street, 1GW4, and then 1GW5. Actually, 1GW5 was the first one where we were starting here. So that was over Century Boulevard. Let's go to the design phase, and then the design phase, the whole process was looking more or less like that. So we came with a concept design to our customer, and then we worked out the concepts. We aligned our concepts. We listened to the ideas and the requirements. That is how the final geometry was worked out. Then again, when we have really the final geometry worked out before we pass it to statics, once more we do a peer review with the customer, and then again when this is accepted, we go on with the static analysis. As we have a geometry, we know how the framework will look like. We know the critical cases. This is the moment when we can already start with our analysis. And then if we know that all conditions from static analysis are done, we can continue with production of assembly and general arrangement drawings, design. Then once more, the peer review, when let's say 80–90% of the drawings are finished, or close to finish, before approving then one more peer review with the customer to see if everything, if the drawings that they will receive is what they are expecting. Then if we have a green light, then we go on with approving the documentation, passing it to the site, and then again, in parallel to that, there are material lists created and sent to supply chain management department, which is then organizing all the parts to send them to the site. So then, speaking of the geometry, let's go a little bit more about the details. And here you see 1GW5. Actually, the first segment of 1GW5 was the heaviest, was 170 kips around. Was not the highest, but it had this anchoring block. Plus, it had longer wings on the side. So at the end, that was the heaviest one. So what you see here, and actually one of the most important thing about the balanced cantilever carriages is that you have a carriage, you have a framework at the top, but the most important thing here actually is the formwork, because this is like the place where you put the concrete. So that's the reason why we have all the carriage is the formwork. So every formwork when we pour the segment, every formwork is anchored to the existing concrete in the back. Actually, in our case here, in most cases, this is 1 foot distance of the axis of all these anchors of the formwork plus the leg of the mainframe that you see here. It's 1 foot. It changes depending on the project, but more or less we start from that. And then the formwork is suspended in the front, in the axis of the main beam. This is actually suspended to the main beam. That generates the force here in the front of the main frame, and then this force is transmitted to the rear part where we have the main anchorage of the frame, plus there is a leg standing on the concrete here that generates reaction. And then if you are looking here at these dimensions in feet and inches, maybe if I transfer them, if I change them to meters, that makes a little bit more sense, because this is a proportion 5 to 4, and if you know that proportion and you would like maybe roughly even on the job site calculate the reaction forces acting on the foot or acting in the back, that this proportion 5 to 4 makes it pretty easy, because if you have this load X here in the front, if you use this proportion, then in the back you have 125x, and the summary of these two gives 225 at the leg. So that's the thing here. Then one of the first thing also which is required for a global analysis of the bridge, checking the structure when it's loaded with the balanced cantilever carriage, is to provide to a bridge designers a self-weight of the carriage, like the complete self-weight. In this case, it was around 135 kips, and the center of the gravity. So actually where this load should really be assumed at. And that was approximately 5 feet from the axis of the main column here. When I say main column, I mean the center point of the main frame. So this whole framework. So if this axis of the main column was 1 foot from the pouring joint, then it's around 4 feet from the pouring joint where was the center of the gravity. So that one on the left is actually important for a global analysis of the bridge, I assume. But also interesting part is that one really movable thing here is the carrying rail. See that one in the pouring situation is located on the existing concrete. We always try to make this that it doesn't stick above the segment under construction, just to not to be an obstacle to finish the upper surface, for example, or even about reinforcement. Then when this segment is done, the cross section, the rail is launched forward on top of the existing concrete, and then the carriage is moving on top of it, and then this carrying rail weight was 20 kips. So that influenced by by 2.5 feet the center of the gravity location. So once more about the most important thing, the formwork. We have several panels here. So what you see here actually is a cross section AA. So that's in the plane of the main column of this frame. This is above the concrete where everything is anchored, and BB where everything is suspended. So the formwork, this one is the internal formwork, and as I said before, every formwork is anchored in the back and suspended in the front to the carriage, anchored in the back to the existing concrete. So that's what you see here, and the suspension in the front here. And then we have external formwork. In the case of the external formwork, this is connected wall and the slab formwork, to which, and that is in that case actually it was only one anchor here, but also this formwork was supported on the bottom platform, because when we have inclined walls, it's not only the concrete pressure that has to be taken by the formwork. So for a concrete pressure, we have a tie rods going through the wall, but when the wall is inclined, there is also a concrete load which has to be taken down, and that's why we have these spindles here. The same here. And then bottom platform also anchored in the back, in the bottom slab, in this case, in the concrete, in front suspended at the same level, but this is suspension to the main beam. And then interesting thing is that on the external part, beside, it's like outside of the concrete deck, we have a suspension to the truss and to the beam that is used in several situations, that is used to lift by hydraulic jacks this whole platform from the ground. It was not done like that here because of the traffic mainly, but this is possible also to lower. But also when we want to launch the system, so we cannot launch when we have all these anchors in the concrete. So when we are removing, after putting the anchors from the concrete, the platform is suspended on these external tie rods. This is actually DW26, and anchors normally we use DW40. So that's what you see here: front suspension, side suspensions of the bottom platform, and this is here anchorage in the concrete. That's already a bottom slab top view. Yeah, here is a putting joint, and these are these two anchor holes for the bottom slab. Then the complete picture of the anchor sleeves location. That's the same story here. Top slab, we have we need, in that case it was needed 8 anchor holes in the top slab, plus 10 anchor plus 2 anchor holes to erect the next segment. So the picture on the left shows external formwork, also part of the bottom platform. So it's one anchor here, as you see. The same symmetric situation at the other side, and you have 2 anchors here, and this is because it was 1GW5, where we have added additional additional pair of anchor sleeves for every frame. That's actually, these squares that you see here is the place where is the main frame standing. That's a location above the wall of the main frames, and this is the anchorage. So in case of 1GW5, we had to turn with the carriage, so we couldn't bind ourselves to one hole. It's much more comfortable to have 2 holes. I will show you in a moment why. And then the anchors of the formwork. Every anchor was pretensioned with the force before putting. And then of course there is required a coordination with bridge designers due to PT locations of the PT cables. So it's always a challenge at the beginning to fit all these anchor holes between the tendons. And let's go to reaction forces. So I was saying that these squares are actually the location of the main column. So that this center part of the mainframe. Reactions here were the highest actually from the whole arrangement, was 143.5 kips. And then in the back, I'm just giving the maximum from the whole project. I'm just giving the maximum forces, and that was spreading between 20 and 25 kips for each of these anchors. And then formwork, internal formwork, 12.5 kips for each of these two. Then external formwork, a little bit less, 10 kips of reaction force. And in the bottom slab, a bit more because it's taking a bigger slab. It's also taking a part of the load of the wall, 38.5 kips. That was the maximum for each of these two. And all of them were pre-tensioned with the force, with the hydraulic jacks, with the forces given here, 39 in the upper slab, 42 around, of course, because with the pumps that we have, you cannot really get the exact match, but around that. Speaking of the anchor sleeves, of course, this is what we always do. We provide anchor sleeves location for the complete project. So we see here 1GW1 is just holes. I'm not zooming in, but it was just points where the holes are. And it's also important to say that normally PDF is not enough. We provide DWG to give it already to surveyors, so for them it's much easier to set all these holes. But then if you look at 1GW4 and 1GW5, beside the anchor holes locations, we were also providing the carrying rails location. Especially here, it was important because of the turning. The thing is that when you turn with the carriage, and if you have in mind that first you have to move on the new segment, you are moving the carrying rail on top of it. So the first thing that is moving during the launch is the carrying rail, and then already the carrying rail is kind of a track for the whole framework, which will be moving on top of it. So carrying rail is actually the important thing to be set in the proper position to be able to turn with the carriage, because it's always first the carriage, first the carrying rail, then the carriage on top of the carrying rail. So that's why 1GW4, 1GW5, you see the curve, we were also providing the carrying rail location. And then the anchorage. Here you see the longitudinal section that I was showing before, and we'll be talking about this part, the rear anchorage of the mainframe. In 1GW1 and 1GW4, we used only anchors in the axis of this rear anchorage. So one anchor per side of the frame. You see at the beginning, for the first step, there was a diaphragm. So in the diaphragms, normally we have embedded anchors, so they just stay here. Yeah. And later they are removable. So that's what happens here, goes through the sleeve. But then when we have 1GW5 and a pretty small radius, that means that we need to turn a lot, then we didn't want to be fixed on that one location, because the hole even here in the beam is very small, so it doesn't give much tolerance. In order to have more tolerance at positioning of this rear part of the complete carriage, we implemented this additional beam, kind of a spreader beam, which was anchored by two DW26. So in that case, in case of a one, our standard approach DW40, here DW26. And also if you see when for the first steps we had the rods embedded in the diaphragm, and then we had removable rods later in the next steps. So we had extra beams and embeds. Then, of course, the deflections. The deflections are very important. They are a very significant part in evaluating the precumbers, because every segment, when we prepare to pour concrete inside the formwork, the formwork has to be rise up, and when we start to pour, the formwork is a bit higher than the final position where we expect to have the segment. For that, we need to have precumbers, and to evaluate precumbers, important part is the deflection of the whole system during pouring. We provide that for every pouring segment, and that is normally 2 points at every horizontal panel. So 2 points on the external slabs, 2 points in the internal slab formwork, and these edges here, 2 points on the bottom slab formwork. So the biggest deflection was half foot, not high, not bad, and then the smallest in the last smallest section of 1GW5 was just 4 millimeters. So that's not much. Then, as I was mentioning at the beginning of my slides, we have prepared the final solution where formwork panels, external as well as normally internal, in this case also external formwork, was cut to the size of the segment. So here you see a guy preparing the formwork length for the next pour, and for that situation we provided for every existing concrete segment in that project. We provided the layout, including the cutting line here also, how to cut the formwork, how to arrange the wailers, and how to locate the tie rods. That was done for every segment in the project. Also, our carrying rail here were used to align the both sides of the both cantilevers, both sides of the span before pouring the stitch. The carriage is approaching, so we already have here the carrying rail. Normally there is one side of the span which is slightly lower, and to level these both sides before pouring, there was an idea actually from Flatiron to use our carrying rails. So that's actually what you see here was a concept from us how that can be done. That was aligned with the bridge designers, and at the end it was actually pretty similar. So the carrying rail was used. You can see these beams here anchored to the concrete, also here anchored to the concrete on the other side, and the leveling could be done with the hydraulic jacks. So here is a top view that you see. Here is a stitch, and look like that. So you see here our carrying rails used to level in a vertical direction these two sides, but then there were added extra beams was kind of a distance beams. You see also the jacks to keep the distance between the sides of the span. When this is fixed, we can then pour the concrete. Of course, before pouring the concrete, formwork needs to be adjusted. And as I was saying at the beginning, every formwork, when we pour the concrete, in the back is anchored to the existing concrete, in the front is suspended to the carriage. That is not like that. When we do the stitch section, normally formwork is anchored in the back and in the front, actually in the place where it was normally suspended using almost the same gear, but then the front is also anchored to the concrete at the other side, and the carriage is actually standing here beside that. This is a kind of a ballast for leveling of the bridge, but it's just standing there to pick up the formwork later, move back or lower it. So it's just, then it becomes a device to transport the formwork, because the formwork is anchored completely to the bridge, and before doing a stitch normally, and also that happened here, the top slab formwork is removed, because later when we close this slab, it's very hard to remove the internal slab formwork, especially as one piece. Then you have to dismantle that. Maybe you manage. But then here, internal wall formwork was left as a wall formwork, but then the top slab was formwork was stick built, so it was just done on the job site, prepared on the job site. So that was a stitch done, and not long here. You see one more view, one GW5 after putting stitch section, and then the next day you can see that. So that was my last slide. I hand over to Nabil. You'll speak more about assembly.
Thank you, Pawel. We're going to stay with 1 GW5 and over Century Boulevard. Century Boulevard is, we're going to talk a little bit about assembly. Yeah, next place. Thank you, Pawel. And it's 6-lane traffic and 3 on each side. The contractor was permitted actually for assembly to close 1 lane only, and by bend 48 to the pier, what we see here, and the staging area. Working hours that were scheduled between 10 p.m. and 3 a.m. in the morning, basically next day when traffic is very low during the night, and we're pre-assembling everything on the ground wherever we could, the carriages, the platform, and the formwork. We see here the carriages, the main beam, and the platform on the left. And it took, Pawel, next page, please. It took us one night shift to lift the platform in place, and basically 2 shift to set the carriage and the formwork. So here we are lifting the platform in place, and it's about 45,000 pounds. We can see on the top right, on the top picture there, you see 2 needles, I-beams sticking out, cantilevering from the pier table. And those basically, as Pawel mentioned, the platform is going to be anchored at the bottom slab with 2 anchors, but the front of the platform has to be suspended. So usually in a case like this, we did this differently. When you stage the ballast cantilever, you bring the frame first, stick build the frame, put everything on the deck with the pier table, and later, lift the platform, and you can use the jacks to jack it up with 4 rods up in place, or the crane, hosted with the crane. In this situation, it was best to work everything, pre-assembled everything on the ground. It's safer wherever we could, and lift it into place. So now we started, backwards, starting with the platform, suspended from the front with 2 I-beams, as we see over there, and later we brought the carriages. Next page, please, Pawel. And here we see the carriage coming up with the main beam in the front and the truss. Of course, you got to provide the center of gravity for the crane guys, and it was about 44,000 pounds to lift, I think. This is the yellow frames, PERI. They are pretty light. They are 5 tons per frames. Next page, please, Pawel. And here we can see as well the counterweight on top of those I-beams. That's what we use to keep those I-beams cantilever. Of course, it's all calculated and making sure everything is safe. And now we are placing the main frame on the carrying rails. As soon as they are secured, the platform is suspended. We took down those temporary I-beams and the counterweight, concrete counterweight. They were removed. Next page, please, Pawel. Yeah, and here next day we are basically lifting up in place the pre-assembled formwork. Of course, this one was done with 1 lane closed of traffic close to the pier. Went for it. All right, go ahead to the next page, please, Pawel. Yeah, basically 3 shifts, 3 nights to complete the project, lifting, the platforms and the carriages pre-assembled with the pre-assembled formwork on next day here. This picture driving actually from the hotel going in, and that's what you see in the morning was done during the night. So, and go ahead, Pawel, to the next one, please. Yeah, I mean, we see with this slide some drawings here, and this slide basically shows everything came together, you know, perfect because of the planning process and communication with all parties, including, you know, the crane company and the contractor and everybody involved to ensure, you know, as a team actually work together to ensure the safest operation possible. Next page, please, Pawel. Disassembly, touch a little bit on disassembly. Also was a little bit, I mean, again, it's job site conditions. You adapt to the situation. Like I said, lanes, you know, we were not allowed to close the lanes. Now on this one here, as possible, low traffic, they close 2 lanes on each side. We end up dropping the bottom platform in on the flatbed, move it to the next project, and two situation we can, and the carriages that can back launch to the pier table and disassembled at the pier table, and sometimes as well we did basically pick the carriages from the top and put them in a flatbed and move them to the next segment. Of course, you know, you got to have permits and all that, you know, planning for all this. Pawel, next page, please. And here we can see the platform coming down on a flatbed here, and traffic was shifted around as needed. Next one, please. Can you hit another one too? And here we can see as well, you can lift the carriages to the from the closure pour, put it on a flatbed, or have the carriage, and we did both ways, travel backward or launching backward the carriage to the pier table for disassembly. Next one, please. I think that's it. If you have any questions, give it back to Greg and Wade, and thank you very much. Thank you.
Well, thank you, gentlemen. Great presentation. And we do have a few more minutes for Q&A. Folks, if you need to leave at the top of the hour, that's fine, but we will run just a little bit long because we do have a number of really great questions we'd like to cover. So Wade, I'll turn that over to you then.
Okay, very good. Well, thanks, Nabil and Pawel. That was a great presentation. Lots of good detail in there. Got a few questions from the audience that we need to go through. Some of them are kind of general questions, and some are a little bit more specific about the construction of the project. So let's see here. First question, is there a limit to the capacity of the form traveler system? This was a fairly narrow cross section here, but you know, how do you set up your form travelers if you have a wider, heavier box?
Well, I mean, I will answer a little bit this question, and Pawel, maybe you can back me up on this one. So the form traveler we have on this project, the limit for it is 200 metric ton for basically the 2 frames that can carry, max at, let's say, 5 meters, which is about 16 feet plus, okay? On the segment. Of course, you know, sometimes you have the heavy segment is the first pour. At LAX actually was backward a little bit. The heaviest segment was almost, I mean, the longest segment was in the front instead, you know, the middle one. Again, that's basically maybe for static or for the architect who will look on the curve, or, you know, this is a bridge designer choice. But again, you know, the one we had at LAX is about 200 metric tons. We have the other one, we carry 2 other carriages that it can go all the way to 300 metric tons and all the way to 19, I would say, 0.2 foot segment length we can do. But again, depend on the weight. Pawel, I mean, if you have anything to add, you can.
I mean, yeah, these are one of the lightest frames we have, and here these segments were not so big, so it was far from utilizing. It was maybe close to 50% or even less utilization of these frames. And then, if the question is also about the size, when we get wider with the cross section, of course, if this is very wide, this is a little bit reducing the capacity of the frame. Yeah, but in general, we can say that this frame that was used here, 200 metric tons at 5 meters, for cross sections maybe 16 meters wide. Yeah, which is I don't know how many feet, but it was not even close to the limit here. And we have the stronger frames also. And then also, if the cross section is getting wider and bigger, often the designers make it not one cell box, they make it 2 cell boxes or even 3 cell boxes. Then there are walls, and then on these walls we can add another frame if necessary. So this is how we solve it. Yeah.
Yeah. I
Yeah,
hope that answers
that's
the
great.
question.
Okay, thank you. Yeah, no, that's good. Couple of questions specifically about the project. We got a lot of questions about concrete finish and how that's achieved and what was required. So I guess we'll just start out. Do you know what was required in the project specifications as far as concrete finish? Was there a requirement for like steel form panels, which obviously always generates a lot of discussion when you're using form travelers, or what were the requirements there for that concrete finish?
Well, there is of course a requirement, and it was close to I think Class A finish. They had to have, but again, comparing to steel or using plywood, I mean, usually we do recommend to sit with the customer, and they did. First of all, we had a mock-up on a job site to make sure, looking at the finish, and has to be approved by the bridge designers and the contractors that and we do recommend, we have recommendation on a plywood to use in this kind of work, and usually the high-end plywood to give us a good finish, and it's very comparable to steel finish. I mean, there is no difference. And for the pours you have, I mean, going like 50 to 60 pours should not make a difference, so yeah, but we did have some requirement for the finish, and we had a mock-up on site, and we had to go through some approvals before we moved forward.
Okay, great. Yeah, and it looked like you guys were using some kind of a plywood
birch
panel with an overlay on it. Is
Yeah,
that correct?
that was yeah, it's correct. It's a film on it, and it's
Mhm.
a birch plywood what we used on this one here, and it's recommended for this kind of work. It gives you a very good finish, a good result, and as well, it's very durable, and it goes, for many pours, almost, you can depend on how it's treated on site, you can get up to 60 pours with that, but we didn't have that much on this. So.
And you discussed the fact that the idea of having a trailing platform was discarded at some point during the development process. What was the access for finishing off and doing the concrete finishing, patching, all that good stuff on the trailing segments?
Well, they did use a man lift for this one, and honestly, Pawel, I don't know. Do you have any idea what they use
I
beside
think
man?
in case of that bridge, it was accessible from the man lift.
Yeah.
So that's how it was done, I guess.
Yeah, that's what it was done that way. Instead, using trailing platform. We discussed it. Was a good idea at the time, but later on, they said, man lift will do for them. So, but it's possible to have that too as well.
We have that in some projects. Yeah, we apply it above the river. Yeah, that makes more sense then.
Yeah.
Right. Yep.
Yeah.
Absolutely. Okay. You had some great slides in there about how you installed the bottom form deck prior to putting the overhead frame on. Did you use that same technique for all of the spans that you did with the form travelers?
That's what they did, yes, on this one. It was easier for the contractor to have the platform pre-assembled and install it that way, and it did work. So yeah, I mean, usually, for us at PERI, this is the first time we did it that way, and and we were consulted. We consulted with the customer, we talked to them, and yeah, it did work. I mean, it's just one of those things, live and learn. You live on you learn from the job sites. Yeah.
Yeah.
I think I think it's very fast. It's even faster. So when the technology was already there, how to do it, Let's just do it until the end.
Yeah, it was faster. We did simulations. We went through all the details, and yeah, it was way faster than what I call, doing a stick build on a pier table.
Mm-hmm. Yeah, really clever method for getting that bottom form deck in.
Yeah.
That was really cool.
Yeah.
All right. How did you approach the forming and pouring of the internal anchor blisters for the PT10s?
Well, the blisters are the key question. Always the blister, what we do in the internal formwork, we give sketches and we give some material for, but usually they are built on site.
Exactly.
We give material, yeah, but they are done on site by contractors because you're never gonna hit them right on paper. We do that on paper. We give ideas and we put it in there, and also we leave it to the site to do what we call, there is field measurement and all of that, and the equipment is there. So there is some, I would say, timber built attached to the formwork. So we count for it in our formwork, but still we leave it to the site as well to have some liberties how to deal with it on site.
Yeah. All right. And this is probably more of a contractor question than you guys, but do you happen to know what the crew size and the cycle time was for the form travelers?
Well, yeah, depend. There is a learning curve on that. I mean, the productivity numbers on this, I mean, it is a contractor, but I can tell you for the installing the form, I would say it's around 550 man hours for GW5, but there is a learning curve as well associated with that and GW5 was one of the hardest one, but for GW1 and 4 was around 300, 400 man hours, way easier, so I mean, so for launching, depend, I mean, you have about 600 to all the way to 800 man hours. So, so you get the cycling was 5 to 6 days, depend on the, and it's a project like this, what I would say is usually is not the formwork is the issue, it will be the rebar is what holds the formwork. So if you have the rebar, in place and they are, on time, I mean, formwork with cycling should not hold much. So, I mean, inside I can share other because this is contractors number. So, I mean, if they can set question, on site, I can give more details on that.
Yep. No, that's great. Thank you. Appreciate that information.
No problem.
Several questions here about the geometry control and what was the maximum difference in the elevation of the two cantilever tips amongst all these different spans that you guys encountered when you were doing your closures?
Pawel, maybe it would be your question.
It's not really, I don't have that data. That's
no, but we can come up with it if you later on. Yeah. If we can send it on the site, send an email. Yeah.
Okay, that'd be great. Yeah, understood. That's kind of a contractor and erection engineer question, but figured we'd toss it out there in case you guys knew. All right. Speak a little bit to the split of responsibility between the bridge designer, the formwork, or in y'all's case, the form traveler supplier, and the construction engineer when it comes to checking connection capacities, local capacities, and then obviously global capacities of the bridge.
Yes, there is that. There is a coordination between, the contractor, of course, they coordinate with their structural engineers as well. They put us in connection with their consulting engineering firm as well. So we talk to them. There is a lot of work behind it before we get to the first concept. And we do a peer review, and later we go with PERI. We do our own calculation, our static calculations, and we do submit it later to the contractor for peer review. They have that engineering they go through it. There is a lot of question back and forth before getting, to get to the PE step. And yeah.
And was this a design build project? You may have mentioned that. I don't remember.
Don't remember mentioning that. I don't believe it was design built. Dan?
Okay.
I don't know if he's there, but if he knows. I can check on that, to be honest with you. I don't have the information here in front of me on that one.
Okay, no, that's fine. Was there any effort made to try to configure the form traveler setup to allow like prefabrication or pre-tying of portions of the rebar cages?
Well, there were. I mean, that was left to the contractor, and that's what I was saying. You know, the first segment there was some learning curve on that one, and and they did figure that out, of course. And they had to, there is pre-assembly, I would say, on rebar cages beforehand. Some of them were stick build. Stick build, was like was taking too long. So they did, like I said, there is a learning curve for how to do this. I mean, usually the rebar is the problem more than anything.
All right, and I'll just have you comment a little bit about like lessons learned or problems to avoid. What should the designer be mindful of or anticipate when designing a bridge like this to try to minimize any issues or problems that you all may encounter as the form traveler suppliers?
Yeah, I mean, one of those, Pawel was doing in his design presentation, for instance, looking at the anchors, we try to minimize the anchors on the deck that, again, avoiding PT. So
don't finalize PTs. Don't finalize PTs before choosing the carriage.
Yes, don't. That's one thing. So something should have been worth mentioning that we have to coordinate on a PT location and where we're going to put those anchors. So that's why you see in the design and the view plan, we're going to give every anchor location and the surveyor, they have to know where they are at, and we have to avoid those. So that, again, don't finalize the PDs unless, you have that discussion. Anything else, Pawel, you see here?
Yeah, I mean, geometry envelope when it is changing, for example, how the slab, because there are the projects where the slab thickness is changing. I mean, bottom is not an issue, but if we change the shape of a shape or thickness or shape and thickness of a top slab, or the wall thickness is often changing in the projects, the way how it is changing, not close them if you can, wait for choosing a supplier of the carriages, because we are able to fit the system to almost every geometry, but to minimize the effort also on the job site for the people to change this formwork later as it goes, it's better to consult before closing.
Yeah, I mean, it's one of the things you see in the experience when you do this for a long time. When you put the carriages and the formwork up on a deck, you don't want to bring them down. You don't want to bring the formwork down to rework it. And that's what Pawel is going to see. If there is a considerable geometry changes, we like to consider that, okay, we deal with it on a deck like this, saves time, labor, safety is another thing. You are in the middle of nowhere, try to bring those carriages down or take it back to the pier and start welding and cutting wood and this and that. So, and that's what I say, consulting with the formwork and the ballast cantilever, understanding what we can do. And it's very important, I think. It's just to avoid all of those ahead of time. We would like to be on the deck, keep going, don't stop.
Yeah. All right. And this is kind of a related question. For the curve bridge, were the tie-down sleeves located consistent relative to the segment, or were the tie-downs adjusted, for farther or closer to, say, the web wall lines as you went through the curves?
Pawel?
I'm thinking how to approach that. Generally, our anchors are around the wall. If it's a single wall, a single anchor of this double with this spreader beam that I was showing, this is generally in a close location to the wall. If I understood the question properly, I'm not sure.
Yeah, you had a graphic that showed, I think for the 1GW5 bridge, that in the back you had a pair of tie downs and a sort of a little small transverse beam there, and I got the impression that was so that the back end of the traveler could be placed different positions relative to your fixed positions for the tie down sleeves, right?
Yeah,
Yes,
I think,
that was the reason we had them. Yeah.
yeah, you can
So,
you
okay.
can go back to the presentation if you want, Pavel.
Yeah, yeah, it gave us. Wait.
Okay.
Okay.
Page 37 is what you had. So yeah.
So you see, normally we are fixed here to this one axis because here is where we have the anchor. This is one at each side of the frame, so two per frame. And when we have the turn, if we apply this spreader beam and double anchor on it, that beam here, this one that we anchor normally here with one, it has some playroom, you know. And if you look at it, you know, it's like rotating a little bit, so that is required when we turn with the system.
Yeah, allow the carrying rail to, you know, just to shift.
Yeah.
And that's what we did it that way. And you see the embed on the diaphragm. You know, there's just the bottom mushroom anchor. That's its lost item. The rod, you can recover the rod, the whole thing, and later use it as a recoverable
But
item.
also
Yeah.
important to say here, during turning, we didn't have, we didn't want to have these anchor bars in one track, because this is what happening when we just go at the straight bridge. We have one track. There is some tolerance, there is some small playroom in one direction, but generally, if we have this solution like here, then these bars, we have a lot of freedom in placing them, yeah, in both directions, because this is it's a double C profile here, so we can slide it as we want. Also, this beam can slide on this part of the carriage, so that gives a lot of freedom in going around the PTs also in the concrete.
Yeah. Okay, great. One last question. And you know, for curved bridges like this, it gets pretty interesting, and there's a lot of little details there. Was there an effort made to curve or warp the web wall forms, or were the web wall forms corded for each segment?
They were corded. They were
Yeah.
corded, and also we could, you know, I mean, talking out loud, I mean, there are two ways in the system. We could also introduce a turning mechanism to that too as well if we had to, but the whole thing was corded, yes. And that's why the reason the poor segments, you can see they started with the, I think we're looking at, sorry, they started with 12 foot and, you know, with 12 foot and later went to, I mean, to start with 15 and later went,
There's
you know,
15
12,
and then 12.
12,
Yeah.
12, yes. So usually, you know, you should usually do the opposite, and that's what they did. So the way to give it a nice curvature there.
Okay.
Yeah.
All right, very good. Well, once again, thanks for a great presentation. Lots of interesting details in there, and I'll turn it back over to Greg to take us out.
Well, thank you guys, and thank you to those of you who were able to stay with us a little longer today. I know we ran a little long, but it's great information, so thank you. Again, if you have comments on this session, you can email us at info@asb-assoc.org. Again, reminder to follow us on LinkedIn, and also go ahead and sign up for next month's webinar. So with that, we'll close, and thank you guys. Appreciate your sharing information with us today. Great job.
Thank you.
Thank you.
All right, bye-bye.
Bye.